Hello everyone, welcome to our YouTube channel. We are every week doing a new e-MEETUP about what we are doing in our company. And today we are welcoming Vincent JACQUIER, one full-stack developer of our team. Hello Vincent.
Hello.
Vincent is working in data integration for Veepee Tech. What is data integration? Data integration makes sure that we can collect, shape and manage information data about our items, because we are using many different items for Veepee. As I can show you now, we are having lots of different products on Veepee websites. It can be clothes, it can be entertainment, it can be travel, it can be food and beverage, and it's very, very important to have a lot of something to centralize all this data. This data integration product has been developed at the beginning by a company which was named Scalia, and Scalia was incorporated in our incubation program, what we are doing in France, because we have in our Veepee Tech company, obviously, product, IT and data teams, but we've got as well a big innovation program like this incubator center. And for speaking about it today, we are welcoming Jean-Philippe, our head of innovation. Hello, Jean.
Hello, Valentine.
Thank you for joining today. Jean will do a quick introduction about our innovation, so I let you the speech now. Thank you very much.
Yes, good afternoon, everyone. Thank you, Valentine, for the invitation. So I will move briefly on the innovation team, how we work and how we prioritize the different subjects we are working on. So let's start. So yeah, we have a strong support from our founder, Jacques-Antoine Granjon, inside the different innovation initiatives. So we can move to the next one. So Veepee Innovation have a strategy of maximizing short-term growth drivers, anticipating the market changes, and also create a long-term method of self-disruptions. And to support that, we have two main activities. One is the startup selection and evaluation, and one is focus on innovative project internal development in collaboration with the different teams internally present at Veepee. So next, I will speak a little bit about our process of selections and how we decide on the different solutions that could answer the need. So everything starts by project sourcing, where we identify a need or a problematic that we present during our innovation committee to prioritize the different projects that are that need to start ASAP, and the ones that are not as prioritized. And after we move on identifying external solutions that could be brought by startups, and decide on the move if we would like to use an external solution if it's not strategic for Veepee to capitalize on a solution, and if it's the case, we decide to develop it internally in collaboration with teams. And at the end of the project iteration, we present the results during the innovation board to decide on the next step if an investment or integration is evaluated. Just a bit more focus on the next slide on how we select and how we prioritize the different subjects. So there is a duality between business and tech. So we always start by evaluating the playground. So starting from the global entity and the issue to identify the potential that a solution can bring. And after we move on the assessment of different technical criteria on the feasibility, the different KPI to follow to assess the result, the performance of the solution, and the breakthroughness. And in the end, we always consolidate the value creation bring by our project. So that's it for me. I leave the floor to Vincent. I'm really interested to know more about Ruby. So since a long time ago, I'm a big fan of the language, the readability, and also the Rails ecosystem community and philosophy.
Thank you very much, Jean, for this highlight about innovation. It was very interesting. Vincent, if you want to begin, thank you very much.
Yes. So, hi everyone. Today I'm going to talk about the polymorphism in Ruby. So, first I will introduce myself. Then I'm going to explain what is polymorphism. And I'll show you two examples, so a simple and a more complex one. And then I'll show a possible implementation using Ruby on Rails and Activerecord, which is the most popular ORM in Ruby. And finally, we'll discuss about the polymorphism in other languages. So who am I? My name is Vincent JACQUIER. I'm a developer at Veepee since 9 months. But I started using Ruby nearly 4 years ago. For those who know, I'm in the tribe content preparation. So our mission is to introduce and provide standardized content, for example, media and data, for all clients' articles. I'm in the team data integration, so who was previously a startup named Scalia, which is our actual tool name. So what is Scalia? Well, it's an article data compliance platform that will facilitate the standardizations of partners' data. For example, standardize the article size or color to match the Veepee nomenclature. So let's say the partner use the size small, medium, and large, and Veepee use S, M, and L. In that case, Scalia will convert the partner's values to match the Veepee values so that it can be used in all Veepee tools. Now, what about our stack? Well, we use Ruby on Rails for backend, so that's the most popular Ruby framework. For frontend, we use Vue.js, so it's a JS framework. And if you want to know more about it, check the previous slide, it was really great. And we use AWS for servers, but it's temporary and will soon migrate to Veepee servers. So now that it's done with the introduction, what is polymorphism? Well, it's a concept of object-oriented programming. So there's a lot of things you can do with polymorphism, but in general, you have a few child classes that will act the same as their parent class. That way, all the main logic, or more generic logic, will be in the parent class, and each child will inherit from the parent and will contain a more specific logic. It can also be a method that will accept different parents type, for example, integers, string, arrays, and work as expected, or different methods that will be called depending on the parent type and or the number of parameters. So now let's move on with our first example. In that case, you will have two classes, a cat and a dog. We both have a method speak. And we'll instantiate both classes and call the method speak. So let's run that code now. You see everything's working. Now, let's say I want to add a name, because I want to know which animal is speaking. So we'll create a method initialize with a method current name, and we'll assign that to an instance method, an instance variable. Sorry. Now I will use it here. And here. So now I'll do the same with our dog and copy the method here. Now I need to give them a name. So for the cat, let's go with Tabby. And for the dog, we'll go with Max. So now execute that code. So you see each animal spoke with their name. So that's great, but we've duplicated our methods. So in this example, it's really basic, but it can pose a problem with the maintainability in larger applications. So to fix that, we can use the polymorphism. So let's create a parent method, parents class named animal. And copy our initialize method. So it will take a name and create a default method speak in case the child does not implement that method. So it's our name child to speak. That way I need to inherit from that animal class. And I can remove the initialize method because it's already in the parent. I can even remove the speak method because in that case, it will call our direct parent method. And if that's not the case, we will search for our ground parent and so on and so forth until it reaches the top and throw an error if it's not defined. So now let's execute that code. So you see the problem with tabby, but Max tried to speak, so our parent method was invoked. So far, we've seen that we can reuse the same code with the polymorphism because each parent will contain a main logic. And we can reduce the code complexity, therefore have a better maintainability because one modifications will only impact one class, so technically no side effects. And because each class have only one job, it will be easier to test. Now let's go for our cons. It's not really easy to implement. First, because you need to think before implementing your feature. So decide which class to create and try to think of generic code for parents. Then, if you already have implemented your feature, you need to spend time refactoring your code. And moreover, it can't be implemented every time. So let's say I only have a basic feature to implement. Maybe it will not be worth it splitting into multiple classes, or maybe it's just not possible at all. And additionally, it can lead to performance issues. So for instance, machine need to decide which method or variable to invoke. So it basically degrades the performances as decisions are taken at runtime. So for that, let's check a small benchmark of that first example with and without polymorphism. So we saw that without polymorphism, it ran at 2.9 million iterations per second, whether our example with polymorphism ran only at 2.8 million per second. So it's not a really great difference, again, because it's a really easy example, but something to consider in your larger apps. Now that our first example is done, let's go with our second. So with our second example, we'll talk about the hashes in Ruby. So let's come here. Don't mind the first line, it will be used later. So first, I'm going to instantiate a hash. And what I want to do is assign the hash with a dynamic depth and keys. So to start, we'll go with just a defined depth. Let's say 1, 2, and 3, and assign the word something. So obviously that line will not work because the first two depths was not defined. So we can fix that easily with the operator double type equal. So let's write now. And initialize my hash and empty hash if it's already not already defined. Let's do the same for our second depth, and then we'll access the third depth and assign my string. I will put that string, that hash here. You can see. and execute it. What did I do? Oh, it's here. Yeah, so that's working. But in general, you will not have keys and variables with only one letter. At least I hope so. And because this example uses a defined depth, and you want to assign with a dynamic depth, you need to use something else. So we can, for example, use that piece of code. So it's a lambda, so anonymous function in Ruby. What it does, it will call itself for each key I want to access in my hash and initialize a new hash if it's not already defined. I put a link in the description if you want to know more about it, but I'm sure it will be worth your while. So we can use it and replace our hash and try it now. So it's working. But if I have that piece of code, let's say 20 times in my application, it's not really a great thing because I would duplicate a lot of code. And if I want to change it later on, well, it will impact a lot of codes. So to fix that, I can add a method in the class hash. Select that and call it recurse. That method will return my hash, my lambda, sorry. And I need to write hash.recurse. Now I can execute the code again, and it's working. The thing is that I only have one occurrence of that piece of code in my application, but I have modified a native class in Ruby, so it's not really great. First, because if I want a normal hash in my application, I will write hash.new, but technically I will have that method available. And you don't know what happened or what will happen with the hash class, so it's not really a good idea to modify the native classes. So again, I can use a polymorphism to fix that. So I will create my hash class that will inherit from the hash class, and I will override the new method. So I don't want to overwrite all of that method, so I will call its parent, so super, and I will give a block. So the same as our lambda here, I will have two parameters, so a hash and a key. So I will access my hash with the key and call myself again. It's really similar to that code. Now I need to access my hash.new, and then I compile and everything's working. The good thing is I only have one occurrence of a piece of code, and if I want to have a normal hash in my application, I will not have that compartment. If I want that, I need explicitly the myhash.new, so it will be easier to test. Something to consider if you do that is that if I have some conditions which will depend on the object class, let's say I will put string, so it's a hash only well if h is a hash. So if I do that, execute that, you see that the class is my hash, so everything's working, but the condition is false because the class is my hash. To prevent that, you have a few options. For example, you can use a .superclass that will search our direct parent. In that case, it's a hash. Or because there's another method, so the method is_a, so is a hash. You see it's a hash because that method will search on our class and its parents. And that concludes our second example. So now let's move on with the third. Now we'll use Rails app and Activerecord. So Rails is the most popular Ruby framework, and Activerecord is the most popular ORM in Ruby. Now for the database, we have three tables, so a notifications, a comments, and a catalogs. I want to be notified each time a catalog and a comment is created, so I need to link the notifications table to both of those tables. So I need to create an index, so in that case, a comment ID and a catalog ID. So let's check that now. For application here, if I want to check the model, you see that the notification have belongs to two tables, a catalog and a comment, with both optional because I don't want to link to both at the same time. And our comment and catalog has many notifications. So let's open a console, a Rails console now to check the interaction between the tables. So notification.first, you see that I have a notification linked to a command. So to access that command, I just have to write .comment. Really simple. And for our second notification, you see that it's linked this time to a catalog. So to access that catalog, same way, .catalog. Now, let's say I want to retrieve all of the notifications for a specific catalog. I'm just going to first take a catalog, and I have to write .notifications. So I have all notifications linked to that catalog. That example is really simple. I have written the seed here. So the syntax is just to give a comment ID for our comment and a catalog ID for our catalog. But if I return to my schema, if I want to add to link new tables to my notifications, for example, a team like that, I will have to create a migration and add a new column in the notification table. So in that case, a team ID. So it's not really great because if I want to add 2 or 3 more tables, I will have to run again new migrations and add new columns. So to prevent that, I can use the polymorphism. So let's go back to our application and change to another branch here and reset our database here. So in that example, if you look at the schema here, you can see that our notification and comments and catalogs are not linked. So to link that, I need to create a new migration. So let's generate migration and add a new column, so attachable this time. You can name it anything. To notifications. And that's that one is generated here. So we're going to add a reference to the notifications table. Its name will be attachable, and it will have a polymorphic true. What it does, it will actually create 2 columns, an attachable ID and an attachable type, because we want to know the type of subject to retrieve it. Now I can migrate that, and I will link the tables in the models. So for our notifications, it belongs to an attachable with, again, the polymorphic true. Let's know that it's a polymorphic column. Now we need to link in our catalog. So our catalog will have many notifications as attachable. That's really important. And we can even throw a deployment destroy, because why not? That's what. That's done for our catalog. Now let's do the same for our comments. And we can add a few elements, few notifications in the seed. So let's store the comment in the catalog and create a new notification. So create with our user ID here. And this time, I will not need a catalog ID. I will just write attachable, so that's our column name, and give directly an object catalog, an Activerecord object, so that he can write on his own the attachable ID and attachable type. Now we'll do the same for the comment, and we'll apply again our seed. Okay. So we'll apply the seed again. And open a new console and see the differences between the two examples. So we'll check our notification first. So you see that it has an attachable type catalog and an attachable ID. So to retrieve that catalog, it's not .catalog, it will be .attachable. That's where you can retrieve it for our second example. So we can check it. So it's linked to a command this time. So to retrieve that command, it's the same as the catalog, so attachable. Now you have your command. And if you want to retrieve all notifications for a specific catalog, just need to write first here, and you need to write .notifications. So nothing changed with that command. That concludes our third example. So the schema, the actual schema changed. So this time I have an attachable ID and an attachable type. You can have 10 or 20 tables linked to notification. You will not need to create another migration. Just needs those two columns. Now let's talk about the polymorphism in other languages. So a bit sooner I said that it can lead to performance issues. Well, that's not really true for all languages, at least the compiled languages, for example, OCaml, C++, and C. Because the method or variable to invoke will be decided when we compile the code. So when we execute it, these decisions will already have been made. I also told that you can use a polymorphism with a method that will accept different params type and work as expected. That's not really possible in Ruby, so we'll see that in C++. So first, create a new file here. And we include our basic libraries. So the string and string. And we're using a namespace, std, because I don't want to write it every time. So we create a void method print that will take a string s, and it will update it. So s and line. Now we're going to create another method print, which will this time will take an integer. And same as before, it will display it. Now let's create our main and call two method prints. First one with a string, and the second one with an integer. So let's compile and execute that code. So see, it's a string and 42. So it worked. Now I also thought that it can be different parameters type, but different numbers of parameter too. So let's check that now. Create a third method print that will take a first parameter string and an integer. Let's affect that. And those prints. Now let's add a second print method that will this time take 2 strings. And we'll call them here. So let's print first the answer. And 42. And our second print method that use a string 1, let's simple, and a string 2. Now let's execute that code and compile it. Oh yeah, so it's 2 here. And that worked. So you see the answer is 42 and string 1 and string 2. So we successfully called 4 print methods, even if they have the same name, but different parents type and number. And that concludes our part here. So now if you have questions, volunteer.
Thank you very much, Vincent. As far as I'm concerned, I'm seeing no questions. But I think I'm assuming it was pretty clear. In any case, obviously, if you have, you still can go on our social media, register to Twitter, LinkedIn, YouTube, or Medium, and contact us directly. Thank you very much, Vincent. Was very.
And I've written my contact for Slack, GitHub, and email. If you want, feel free to contact me if you have any questions.
Thank you. Have everyone a nice day and see you next week for a next meetup. Bye.
Bye.